Hello students, welcome to Sreenath Academy. In this video, we are going to discuss about the symmetry, which is the 14th chapter from 7th class CBSE Max. You know I am Karthik, we are creating videos on all chapters, on all subjects from class 1 to class 12. So please do subscribe our channel, also like our videos, share our videos, don't forget to hit the bell icon so that you will get the immediate updates from us. Okay students, so without wasting time, we're going to start this session with full of energy students. Okay. So symmetry, this is a chapter we are going to discuss now. And now we will see the overview of this chapter. After that, we will discuss each in detail. Later, we're going to see the summary of this session. Okay, students. So how many of you are interested? Yeah, give me a like. And one more thing, students, we're also providing the tuitions in addition to the classes, so please do use them. So go through the description, there is a number, just call to that number. Okay students, so now we'll start this chapter, that is okay students, we'll see the overview. So this is the introduction, but if you see in the nature, in our constructions, in our textiles, in our dresses, in our so many patterns, there are so many symmetrical designs are there. Okay, if you see, this is in the architecture, this is in the engineering, and in the nature also there is lot of symmetry and lines of symmetry for regular polygons. What is meant by line symmetry, and what is meant by regular polygons, and the line symmetry for regular polygons? We are going to discuss deeply about that. And play with punching game. There is a punching game you can play after doing it, and after completing this there is a rotational symmetry. Okay students, so what it is? Rotational symmetry. So what it is? Clock. No, have you seen the clock anywhere? So you may see it in your house or in your home or in your college or whatever it may be, that is school. And after completing it, we're going to discuss about the line symmetry and the rotational symmetry. Okay students, so difference between the both and both things. So this is the end of the chapter students. Okay, so simple chapter, you don't worry about it, and we'll complete this chapter. Okay students, so now we will start our discussion regarding this symmetry chapter. So if you see, it is the building. So regarding the buildings, there is in the architecture there is a symmetry. This is the car, it is the engineering design. So in the engineering also there is a symmetry, and it is the nature, in the nature also there is a symmetry. So symmetry is everywhere around us. As students, yes. And in the case of jewelries also you may see, and in the case of clothing you may see some symmetrical designs. In the case of artists, professionals, so in every field you will see the symmetry. So symmetry is somewhat looking beautiful, that's why in everything there is symmetry. Okay friends, and all manufacturers and all, they came from the ideas of symmetry. Okay students, and in the tree leaves if you see, they are symmetrical, and religious symbols and rugs and handkerchiefs, if you see handkerchiefs, so many of it are having symmetry, and in the case of flowers are also having the symmetry. So everywhere around us, in the nature, in the constructions, in the engineering, in the architecture, in the designs, in the clothing, in the textiles, in the buildings. So if you see the tiles, everywhere there is lot of symmetry. Symmetry looks beautiful. That is the main reason, students. And have you listened the word? Have you have already had a feel of line symmetry in your previous class? Yes, of course. In your lower class, that is in the sixth class, we have discussed about the symmetry, line symmetry, students. Okay. So Suppose if a figure is having any lines in symmetry, it means if there is a line, about that line, if you fold, okay, then the both sides of that line exactly matches. So that is the line symmetry, students. Okay, so suppose if you draw any line, suppose take this example itself. Suppose if you draw a line here, it is line symmetry here. So if you fold the both ends, so they look exactly the same portions. If you see to this side and this side, it is having line symmetry. In this also, if you draw a line around this, okay, it is a line symmetry. So this portion and this portion both are looking same around that line, so they will both will coincide. So this is called as the line symmetry, students. Okay, if you see this design, it is also having the line symmetry. It is also having the line symmetry, students. It is having how many lines of symmetries? If you see, it is having more than one line. It is also, if you draw a line around this and if you fold, you will get a line symmetry. If you draw a line around this and if you fold, you will get the line symmetry. If you draw a line around this and if you draw a line around this, again you will get symmetry. So if it is, I mean, this is the one line, and this is the second line, and this is the third line, and this is the four lines. So four lines of symmetry here in this picture. And here only one line, which is the only the vertical line. So there is no horizontal symmetry here, but here there is vertical symmetry, horizontal symmetry, diagonal symmetry. How much beautiful it is. Okay, students, if you see here also, it is having the vertical symmetry, horizontal symmetry, students. If you see how beautiful it is to look, and it is also having the symmetry around this diagonal, so it is having the symmetry. How beautiful that picture is. So once again, I'm reminding you that what is meant by line symmetry. You draw a line, and if you fold that along that line, then the both portions of it exactly look same. So it is called as symmetry, students. It is called as symmetry. So that is the beautiful case here. So, and those lines are also called as axis of symmetry. Suppose if in the case of T, if you observe here, so around this line, this is the axis of symmetry. Here it is the dotted line of students. So if you write it on paper and if you fold it, you will get this symmetry, students. So the portion to this line, left side and the right side exactly matches, exactly looks same, no difference in it. And if you see here, it is also having the line symmetry. Along this line, if you fold it, so it looks like exactly the same, no difference in it. So it is having the line symmetry. So on these dotted lines are called as axis. These are called as axis of symmetry, friends. Okay, symmetrical lines are called as the axis of symmetry. If you see here, this is the line. Okay, so if you fold it, if you see this side and this side, both are looking same. So it is the vertical symmetrical line. It is somewhat diagonal symmetrical line, but here if you see, it is the horizontal symmetrical line. So along this line, if you fold, exactly both things will matches. The left side and the right side, and the top side and the bottom side are as it is the Xerox copies. So that is the beauty of the line symmetry. And that dotted line or that line is called as the axis of symmetry, students. Okay, so that is the meaning of line symmetry and the axis of symmetry, students. So lines of symmetry for regular polygons. So here some words come. First thing is polygon. What is meant by polygon? Have you any idea? If yes, just comment below. Okay, students. So polygon. First thing you have to know about closed figures. Closed figure. So I will draw some figures. So please observe all these figures. Please observe all these figures. Please observe all these figures. So out of all these figures, I have drawn some planar figures, two-dimensional figures. Okay, out of all these figures, which are closed figures? Can you tell which are closed figures? And which are open figures? Which are closed figures and which are open figures? Try to guess it, friends. Try to guess that. Which are closed figures, which are open figures? Try. Try to tell. Come on. Yeah. Now, what is the definition of closed figure? So don't worry, don't think deeply. It is so simple. What is the meaning here? It is closed. It is open. So what is the meanings of those words closed and open? Open means open, closed means closed. Simply. So if any figure is opened at any point of time or in not at any place, then it is open figure. If any figure is closed, then it is closed figure. And observe according to the definition. If you start with this circle, if you check the boundaries of this figure, so is there any opening in the boundaries of this figure? No, it is fully closed. It is fully closed. So it is called as what? What is it called? What does it call? So it is closed figure, friends. There is no place, so it is closed figure. And now observe this. It started here, it goes on, goes on, goes on, goes on, goes on. There is some small space here. There is some small space here. There is some small space here. So it is called as open figure. Why? Because it is having some opening, no? That's why. Coming to this, is it having any opening? No. So it is a closed figure. Coming to point of this, what about this? It is also a closed figure. Now coming to this, so it is having so many shapes. Zing, zing. So there is no open. Even though it is having many curves, it is not open at all. So then it may be closed figure or open figure, students. Don't worry, it is closed figure. Coming to this, it is also having many curving, so it may be closed figure. No. See here, there is some space here. There is some space here. So if you look at this space, there is an opening here. There is a small opening here. So then it is called as what? It is open figure. It is not closed. It is not closed. It is having the opening. Coming to this, closed. Coming to this, don't blindly say it is closed. If you see here, it is not closed here. There is space here. So it is again open. So now I think you have understood what is meant by the open figure and the closed figure. Okay, so next, I will draw some figures. Observe these figures. So don't worry, all these are closed figures itself. All these are closed figures. Okay, it is a closed, it is closed, it is closed, it is closed, it is also closed figure. So out of these closed figures, can you find out any differentiation between all these figures? Can you find out any differentiation? Can you find out any difference? Try. I will give you 5 seconds. 1, 2, 3, 4, 5. So if you see, if you look at the first two figures and look at all these figures, can you differentiate? I have given you clue. So these two are belongs to one group and all these three are belongs to another group. Can you now make the differentiation between this? Try. So if you see, these are closed figures, these are also closed figures, but if you see, these closed figures are having boundaries, these closed figures are also having boundaries, but the difference is that the boundaries, how the boundaries are there. If you see here, these boundaries are line segments, straight lines. These boundaries are line segments, straight lines. But if you see here, these pictures, the boundaries are not line segments, they are curves. They are curves. So the difference between these two groups is nothing but these are the closed figures having line segments as their boundaries. These are the closed figures having some curved boundaries. Okay. So now I will came to the definition of polygon. Now hope you will understand the definition of polygon. So polygon means it is a closed figure. First thing is it must be a closed figure. It is the first criteria, first eligibility. Next, in addition to the closed figure, its boundaries must be line segments. In addition to the closed figures, their boundaries must be line segments. Then only it is a polygon. Then only it is a polygon, students. You see, all these are the closed figures, I agree, but all these are not polygons. So these two are the polygons and these three are the closed figures. Here if you see, all are not closed figures, some are closed figures. Here some are closed figures and these two are polygons. So polygons means it must be a closed figure. In addition to it, its boundaries are formed by line segments itself. Then it is called as the polygon, students. Okay, so hope you understand clearly about the polygons. Okay, now we will move further, coming to the point called as regular polygon. So there is another definition you have to learn, that is regular polygon. So what is meant by polygon? Polygon means it must be formed with the line segments and it must be closed. Then what is regular polygon? So if I draw some shapes, it is a square, it is a rectangle, it is a triangle. Does all these are polygons or not? Try to tell. Polygons. Why? These are formed by line segments. These are formed by line segments. And these are closed. These are the closed ones and are line segments. Closed ones and the line segments. Then these are polygons. Then what about regular polygons? So if you see, a polygon is formed by the line segments. Line segments are arranged like this. So these line segments will have some length. These line segments will have some length. So if the length of all line segments, so if length of all line segments, lengths of all line segments are equal, if the lengths of all line segments are equal, then the lengths of all line segments are equal, then those polygons are regular polygons. So the two conditions for regular polygon is two conditions for regular polygons is, one is that side lengths and I think you know, yes, you know about the angles also, angles. So side lengths and angles must be equal, must be same. All side lengths must be same, all angles must be same, must be equal. Then that structure, then that figure is called as regular polygon. What it is, students? Regular polygon. Okay. Now again a question arises. Regular polygon means it is a closed figure. Why? Because means it is a polygon and it is a formed with line segments. Why? Because means polygon. So the line segments must be having same lengths and angles must be same. Then only it will be regular polygon. Now what are the examples for regular polygon? So think of some shapes, some figures which you will know that those might be regular polygons. Think, students. So have you know about the triangle? Of course. Equilateral triangle. Have you heard this word? Equilateral triangle. Have you heard this word? Equilateral triangle. Next thing is the square. So can these two be regular polygon, students? You know the properties of square, no? Just think of them. Can these be the equilateral triangles? So yes, of course. Why? Because means in equilateral triangle all sides are equal. And in the case of equilateral triangle, in addition the sides and angles equal to 60 degrees. Each angle equal to 60 degrees. So that's why this equilateral triangle is regular polygon. Coming to the square, here also all sides equal. And another thing is each angle is 90 degrees. So that's why it is a regular polygon. It is a regular polygon. So an equilateral triangle is regular polygon. If you see here, it is the diagram for it. It is having 60 degrees here, it is having 60 degrees here, it is having 60 degrees here. So angles are equal, first thing. And here is the side length here, here is the side length here, here also the side length is here. Side lengths equal, angles equal. Then it is the equilateral triangle. And next, sorry, it is the regular polygon. Coming to the point, square. Coming to the point of square. So square is also a regular polygon, students. Why? Because means square is having 4 sides and 4 of its sides are having same length, equal length. This side length, this side length, this side length, this side length. All are having same length. Okay. And each angle is same, that is 90 degrees. Here angle is 90, here angle is 90, here angle is 90, here angle is 90. So then it is also a regular polygon, students. Next, coming to the pentagon. Suppose if a pentagon is regular, suppose if you thought that a pentagon is a regular thing, then what are the conditions? Then its sides must be equal lengths. So as pentagon is having 5 sides, so all must be equal in length. That is the main criteria. Okay. And one more thing you will know in your higher classes, that all angles in a pentagon are equal and angles are equal to 180 degrees. Angles in a pentagon are 108 degrees. So that we may conclude that pentagon is also a regular polygon. Okay, which is having 5 sides. Next thing is about hexagon. Does the hexagon is regular, students? Yes, obviously it is having 6 sides. Of course, all are having equal length, regular. Okay, and each angle measures 120 degrees. See here, 120 degrees. So it is also a regular polygon. So we are having the square, We are having the equilateral triangle. We are having the pentagon, and we are having the hexagon, regular hexagon. So all are regular polygons. All are regular polygons. It is having 4 sides, it is having 3 sides, it is having 5 sides, it is having 6 sides. So if anybody asks you, so can you give me the example of a 3-sided regular polygon, then you have to tell that it is a equilateral triangle. So can you give the example for a 6-sided polygon, then you have to give that it is a regular hexagon, like that. So now some doubt arises. Okay, we have discussed about the regular polygons which are having sides 3, sides 4, sides 5 and side 6. Then what about sides 2? Can we draw a regular polygon using 2 sides? Can we do it, friends? Can you do it? Try it yourself and comment below. Okay. Next point is that each regular polygon has many lines of symmetry. So why we have to discuss about the regular polygons is it is because of the lines of symmetry. Here the main concept is lines of symmetry. So as it is having many lines of symmetries, regular polygons have many lines of symmetries. If you see here, it is the equilateral triangle. It is having 3 lines of symmetry. One about this line and this line. So each line passes through vertex and to the opposite side. You see it is passing through this vertex. I will draw here. So it is a equilateral triangle. So around this line, it is along this line which is passing through this vertex and the opposite side, it is symmetrical. And around this vertex and this opposite side, it is another line of symmetry. So 2 lines of symmetry. And if you along this vertex, you can draw another line. So it is third line. So if you name it 1, 2, 3, so it is having 3 lines of symmetry. Okay, students. So this is the beauty of the thing. Next, what about the square? If you draw the square, it is like that. So if you draw the square, if you draw a horizontal, not vertical line, so around these 2 things, it is having a symmetry. And if you draw like this, it is having a symmetry. And around this diagonal, so again we can get symmetrical lines. Here we are having 4 lines of symmetry. 4 lines of symmetry. Here we are having 3 lines of symmetry. Here we are having 4 lines of symmetry. Okay, students. So that is the case happening here. Next, 5 lines of symmetry. Suppose here we are having the pentagon now. Pentagon. It is the pentagon. It is the pentagon. And it is having the 5 sides. So we can draw 5 lines of symmetry. Around this line, it is symmetrical. Around this line, it is symmetrical. Around this line, it is symmetrical. Okay, students. And around this line also, it is symmetrical. So there is small change. Around this line, it is symmetrical. And around this line, it is symmetrical. And around this line, it is symmetrical. And around this line, it is symmetrical. So we are getting 5 lines of symmetry here. Beautiful thing now. Next is about regular hexagon. It is the regular hexagon we are having. In this, if you see, so it is the one line. Along this line, there is a symmetry, and along this line, there is another symmetry, and along this line, also there is a symmetry along this line, also symmetry. Okay, 1 2 3 1 2 3 4 5 6 means 3 lines of symmetry. And there are still we are having symmetrical lines around this line and around this line. We are having symmetries, and around this line we are having this. So 6 lines of symmetries we are having. That's the beauty of the subject, my friends. So finally, what is our conclusion is a regular polygon will have many lines of symmetry. Many lines of symmetry. That is the case happening here. And here the concept of line symmetry came from the mirror reflection. Mirror reflection, students. From here the concept of reflection has line symmetry. Line symmetry has came up. So if you look at this A, it is symmetrical. So it is the line of symmetry. We know if you draw A, it is line symmetrical around this vertical axis. So it is line symmetrical. Okay, it is having line symmetry. And now if you take the mirror and if you place at the line, a symmetrical line, you will see as it is. So from the mirror reflection concept, we got the line symmetry, friends. Okay. If you think about this line, this is the horizontal line, dotted line. Does this a line of symmetry, students? No. Sir, both sides looks like same shape, sir. Yes, of course, but the size is not same. The size is not same, students. You see here, sir, around this dotted line, does it having symmetry? Yes, students, it is having symmetry. If you place mirror here, both sides looks same. And suppose if you take car and if you place it in front of mirror, you will get like this. So in the case of mirror, what happens? Left looks like right, right looks like left, top looks like down, down looks like top. This type of fluctuations will occur. So if you see him mouse here, so this is happening here. Okay, friends. So mirror, in the case of mirror reflection, so left right changes will occur, top down changes sometimes occur. If you place along this line, you will left right changes. Suppose if you place along horizontal, top down changes will occur. That is where you are placing the mirror is the concept. Okay, so play with punching game. Okay, students, so are you ready to play the punching game, students? Okay, now take a paper like this and hold it, and after folding it, hold it like this and put some punch on it, means put some hole to it, like I will put some punch to it. I have make it some hole. So have you seen this hole? Punch. So how many holes you are having? You will say, sir, we are having one hole, sir. One. Ding. Now see how many holes you are having. You are having 2 holes. So it is the punching game, friends. Okay. So And if you see around it, this is the symmetrical axis, and if you find out the distance from this axis to the hole and the distance from this axis to this hole is exactly the same. So it is the better example for symmetry. If I place here, we are having the two holes, but if I place, you are getting only one hole, which means it is the perfect example of symmetry, which means when you fold along the line of axis, both looks like same, so this is the example for it. Both look like the same, this is the example for it. Okay, so you can do this exercise using this punching game. Okay, play with. Okay, that's the nice beauty of this subject. And rotational symmetry. So this is the another concept called as rotational symmetry. Rotational symmetry. Okay, students. So before we are going to start this topic, have you seen the clock? Have you seen the clock? How it rotates? Of course, you will see daily. So in this clock, what happens? So there is a minutes hand and there is hours hand. Of course, there is also seconds hand also. So if you look at the hours hand or the minutes hands, how they were moving, so they are moving around a particular fixed axis, fixed point. There is some point that is the center of the clock. There is some fixed point. Around that fixed point, it is rotating. Around that fixed point, it is rotating. Around this fixed point, it is rotating. So it is called rotation. And if the hours hand complete one rotation, if the minutes hand complete one rotation, it completes 60 minutes, covers 60 minutes, and it equals to 1 hour. And suppose if the hours hand complete one rotation, it means then it is almost 12 hours, half day. So, and if anything rotates just as same as the hours hand or minutes hand, then that is called as clockwise rotation. So these are the two important words, friends: clockwise and anti-clockwise. Clockwise and anti-clockwise. So if anything rotate around a fixed point in the same direction as the clock's hands, that is minutes hand or hours hand, then it is clockwise. You see, it is the center fixed point and there is a hours hand and it will moves here like this, which means it is moving down. Is it no? So then this rotation is called as clockwise rotation, if anything moves like this. Okay, what is the anti-clockwise? Opposite to the, and does, if you see, have you ever seen that clock revolve in this direction? No. So that is the direction called as, the direction is called as anti-clockwise. Anti-clockwise is the clockwise and this is the anti-clockwise direction, students. Okay, so what do you say about the ceiling fan blades? If you are watching this video in your room and there is a ceiling fan in your room, just look upright and observe the ceiling fan. So in which direction it is rotating? Does it rotating in the clockwise or in the anti-clockwise? How we can check, sir? So look at the clock ones and look at the fan ones, then you will be able to understand it. And if you are riding your bicycle or if you're watching the spinning of a wheel of the bicycle, it also rotates. So it can rotate in both clockwise direction and anti-clockwise direction, students. And when an object, its shape and size do not changes, the rotation turns an object about a fixed point. Suppose if there is an object and it rotates, its shape is not changing and its size not change, it do not changes. Okay, the rotation turns an object about a fixed point. If you are rotating about a fixed point, nothing will change, yet it rotates. That fixed point is called as the center of rotation. Center of rotation. Center of rotation. Rotation. Important instruments. Okay. And the angle of turning during rotation is called as angle of rotation. Angle of rotation. Angle of turning during rotation. Suppose I will give you an example here. So for full complete circle, complete circle, the angle of rotation is 360 degrees for complete cycle. So for half turn is how much? For full turn it is 360. Then for half turn it is by half, no, 180 degrees. Then for quarter turn it is by 2 again, 90 degrees. Now look at the hand. Suppose there is a hour's hand at 12 and it comes to the 3. So how much angle it has rotated? How much angle it is rotated? Another case, there is hour's hand at 2 and it has came to 6. How much angle it has rotated? So if it completes one full turn, then it is, suppose if it is 12 here, it is completed one full turn here, then it is 360 degrees angle. Angle of rotation is 360 degrees. And it is full turn. So in this case, if the hour's wheel has moved from 12 to 6, how much turn it has taken? Half turn. So how much angle it is? 180 degrees. How much angle it has rotated? Quarter turn. So how much angle it is having? 90 degrees. That is the measurement of clock, students. So have you ever made a paper windmill, students? So it looks like this. Okay, it is symmetric. So it is having any line symmetry? Observe. So there is no line symmetry. Okay, students. But it is having symmetry. Which, how it means? Suppose if you are touching at this and if you rotate it. So even if you are rotating it, is if you rotate it to some extent, then also it looks like the same before. So suppose if it is the A, B, C, D. Suppose if you have rotated it up to 90 degrees, means quarter turn. So the A is here, but after rotation it comes to here. So A is here. But look at the both and forget the letters that A, B, C, D, and look at the figures. If you see, both figures are exactly same. Students. And again rotate one more 90 degrees. Again A goes to here. And again forget the letters. Just look at the picture. It is exactly same. If you place one on another, they will perfectly match us. The definition of symmetry is itself, no? So what we can understand from this? Even though if you are rotating through some angle, it looks like the same, then it is called as the rotational symmetry. So the windmill is having the rotational symmetry. Okay, for every 90 degrees of turn, it is showing the symmetry. So here it is having the rotational symmetry. And what is the angle of rotation? Rotational symmetry angle is how much? So it is 90 degrees. Whenever it is 90 degrees and whenever it is 180 degrees and 38 degrees, in all these angles it is showing the symmetry. But the minimum angle where it shows the symmetry is called as the angle of rotation. So 90 degrees is the angle of symmetrical rotation. And how to complete one cycle, how many times it has to be rotated? How many angle of rotations we are getting? For one complete cycle, A is here and it moves and it has to come here. It has to take 4 times. It will take 4 times. So then its order of symmetry is 4, students. Order of symmetry is 4. So So here there are some words, that is rotational, angle of rotation, rotation, and order of rotation. So the minimum angle where it gives the symmetry is called as the angle of rotation, and for this it is the 90 degrees. And for one complete cycle you will observe the symmetry at 4 points. So it is having the angle of order of rotation of 4. And look at the square. At this point P is there. If you rotate 90 degrees, point P will comes here. But if you look at the figure, it is same. And if you turn one more 90, same, one more 90, same, one more 90, it comes to the original position. So here we are having the angle of rotation. The what is the minimum angle of rotation is 90 degrees. For every 90 degrees angle, it is showing the symmetry. And for one complete cycle, how many times it is showing the symmetry? It is showing 4 times. 4 times. It is showing 4 times, friends. Okay, so that is the case happening here. It is showing 4 times here. Okay, students. So thus the square is having the rotational symmetry of order 4, and its angle of rotation is 90 degrees, and the center of rotation is the center of square, and the direction of rotation is what? It is rotated and in clockwise, and the order is 4. Rotational symmetry order. For equilateral triangle, if you look at the equilateral triangle, what is its order of rotation? If you look at the equilateral triangle, its order of rotation is 3. So for one complete cycle, you will get the symmetry at 3 points. And what is the angle of rotation? That is 120 degrees. For every 120 degrees of angle, you will see the symmetry. Okay, students, that is happening here. So angle of symmetry is 120 degrees, and order of symmetry is 3, students. Okay, and now see here, does it is having line symmetry? No. Does it is having rotational symmetry? Of course, if you rotate for one complete cycle, it will shows, but it does not be counted in rotational symmetry. So every object, if you rotate it 360 degrees, it shows rotational symmetry, and the order of rotation is 1. It is quite common to every object, so it can't be counted. So it is not having rotational symmetry. Does it have rotational symmetry? If you rotate it, no. It is having line symmetry, yes, but rotational symmetry, it takes 1 time. It is having rotational symmetry, friends. Like that happens. And now coming to the nature. So if you see, it is the fruit. So it is having the rotational symmetry? Yes, friends. If you just turn it, it will always show so many rotational symmetry, so many axes. And coming to point, this road sign, does it have rotational symmetry? Yes, it is having almost 4 rotational symmetries. This wheel, does it have rotational symmetry? Yes, it is having rotational symmetry, friends. It is having rotational symmetry. So think for more examples which are having rotational symmetry, and the center of rotation, and the angle of rotation, and the direction, and the order of rotational symmetry. Think of them. Okay, students. And for this, what is the rotational symmetry order? 4 times, angle is 90 degrees. For it, it is 120 degrees. For this, you will get at order of symmetry is 2, and for 180 degrees, you will get, students. Next, line of symmetry and rotational symmetry, friends. So we have discussed about the line of symmetry, and we have discussed about the rotational symmetry. But some of the figures will have both line of symmetry and rotational symmetry. At the same time, some of the figures will not have the line symmetry but have rotational symmetry, and at the same time some will have line symmetry and not have the rotational symmetry. Okay students, look at the square. So it is having line symmetry, almost four lines of symmetry it is there, and at the same time it is also having rotational symmetry. The order of rotational symmetry is also 4. So that is the beauty of the nature. And you will see the rotational symmetry and the line symmetry everywhere. Suppose if you look at this, it is the tire. So it is having line symmetry, students? Does it is having line symmetry? So you go, by seeing it you may thought that it has line symmetry. Of course, some little line symmetry you may think of it. Yes, it is having line symmetry along this axis. It is having line symmetry on this axis. So here also it is having 3, here also it is having 3. So it is having line symmetry. So many line symmetries along every line it is having. And coming to rotational symmetry, does it is having rotational symmetry? Yes, it is having a lot of rotational symmetries. So many rotational axes are possible. Coming to this is the kiwi fruit. So if you see this, students, how beautiful it is, how beautifully symmetrically existed in the nature, students. It is having so many line symmetries, infinite line symmetries. Rotational symmetry, it is having infinite rotational symmetries. So one more thing, students, circle, it is perfectly symmetrical. It is having the line symmetry as well as rotational symmetry so many times, students. So that is the beauty of the rotational symmetries. Try to do this example, students. That's it. So finally our chapter is completed. So now what we will do, we will try to see the summary of this chapter. As we have completed the clear discussion, students, I have explained you each and every topic clearly, so don't worry about it. So that is the symmetry chapter we have discussed in the introduction. So in the nature, in the architecture, in the engineering, in the clothes, in the textiles, everywhere around us, around me, there is a symmetry. There is symmetry. And coming to the line symmetry, if you draw any line, around that line, if you fold anything, both portions of the object are same, exactly matches, then it is called a line symmetry. And line symmetry for regular polygons. Polygons means it must have a closed figure and it must be formed by line segments. And regular polygon means it must have the closed figure and the regular line segments. And the line segments are lengths are same, angles are same. Then it is a regular polygon. Coming to the equilateral triangle. Equilateral triangle is a regular polygon as its sides are equal. Square is also a regular polygon as its sides and angles are equal. Pentagon is a regular angle. Regular hexagon is a regular polygon. So all these regular polygons will have many lines of symmetries, not one line, many lines of symmetries these are having. So, and the concept of symmetry, line symmetry came up from the mirror reflections. And we have played the punching game. And after that, we have discussed about the rotational symmetry. So, rotational symmetry means after rotation, so if exactly matches, then it is the rotational symmetry. And there is a center of rotation and there is an angle of rotation. The minimum angle where you can get the symmetry is the angle of rotation. And next thing is the order of rotation, which means so for one complete turns, how many times you are getting symmetry. That is the order of rotation. And next thing is nature is also having the rotational symmetries, and we have discussed the line symmetry and rotations. Some are having both symmetries, rotational and line symmetries. Example is the circle is a perfectly symmetrical object. So our chapter completed and our summary is also completed, friends. So hope you will understood well. Have a nice day. So don't forget to subscribe our channel, hit the bell icon, like our videos, share our videos, use the tuitions. If you have any doubts, please comment below. Have a nice day. Bye bye, students. All the best.